My job in DIFM, I'm a field trial coordinator along with Paul Hegedus, and we're kind of the interface between the design team that designs the experiment and actually work with the farmer grower to see that it's implemented. And so talk a little bit about some of the challenges we have. Previous speaker already mentioned some of those, and talk a little bit about technology problems. I can relate to that. My first help aid in chemistry class in college was a slide rule. Anybody here still use a slide rule? I didn't think so. My first calculator, you had to plug in the wall and it added, subtracted, multiplied, divided. And I thought that was great because we had to do all of our statistics with a yellow pad of paper and a pencil. So that's kind of where I came from. I'm embraced technology. I'm a computer guy. I always think maybe I was born a few years too early so I could still continue to learn about the great technology that we've developed in agriculture. So when we're working with farmers, one of the key things is develop a good communication rapport, because he needs to understand you, you need to understand him. Develop a way that you can communicate comfortably with email, or maybe he likes phone, maybe he just likes to do a text. We do that, all three. If you're a person that's going to work with the farmer and develop this relationship, you need to be available. That means he can call you at any time. You know, when he's in the field, he may be in the field late at night, early in the morning, and he needs help. So you need to embrace the fact that you're going to be you're going to be his contact to help him solve the problem if he's implementing the experiment. You need to establish trust with your growers so they can feel like they can depend on you. You know, if they ask for something, of course, make sure they're accommodated. And when we're asking for data or any other demand, we need to be respectful that we are working with them at the most stressful time of the year, either during planting or harvesting, or maybe putting on nitrogen application. So just understand the world that he's living in at the time you're making communication. Some of the things that we ask for them when we first talk to them is pretty self-explanatory here. Boundary file, that's the most important thing. We can design an experiment with a boundary file and a little extra information. The design team likes to ask for previous years, either as planted files, harvest files, applied data, so that they get an idea how the experiment is going to be oriented in the field. And if there's not an AV line that's available from the grower, to develop one so they get started in the right place. It's important to know what type of equipment they have, whether it's what color it is, how it's set up. Does it have row control? Does it have section control? What are the widths of each type of equipment? Because you have to design an experiment that all those widths and dimensions are going to fit into one plot. So you can't have different widths of equipment and different widths of plots, because you'll have data that will be corrupted. It's important to know what their normal rates are. If you were not going to do an on-farm precision experimentation project, what would you normally do? Would a farmer plant, say for corn, would he plant 34,000 plants per acre or 40,000 plants per acre? We need to have this so we can design the experiment around that value, so he can see and we can show him what the differences in net income will be for some of these treatments that he's decided that he is going to apply in the experiment. Form of nitrogen is always important. We work a lot from Illinois in the Midwest on nitrogen and seed rate application. Of course, we can do anything that you can variably apply the product. We can design an experiment for that. But how he's going to put his nitrogen down and what form, so we make sure that we have the proper units in the design so he can apply that product at the proper rate. What is his base amount of nitrogen? Does he put fall application? Does he put down a fall application, say anhydrous ammonia, then come back and side dress, after the corn is up? Does he do a spring pre-plant nitrogen application? Whatever that base rate is, again, that's what the values in the shape file or the experiment file is going to reflect, so that we have the proper total amount of nitrogen for each treatment. We have a website, it's a long thing here, but on the DIFM website, we have forms available for him to submit all this information. It goes into our data request folder on the box site, so we can access that and also have a historical record of his information, which is important in analysis. So as far as the equipment goes, what's really important about it is know what kind of format you're going to get. A lot of farmers are into the My John Deere. Maybe they're doing, precision planting. Maybe they are exporting it into another third-party software that you get data from. So understand the type of data that you're going to get, or work with him to have him develop the format that you need if he can do that. But we can use the software to convert anything, most anything that we get from them into a shape file that we use for analysis. David's already shown this, but this would be a typical checkerboard design plot that we would design for an experiment. In this case, nitrogen rate, seeding rate. So with these two designs, we have replications of all combinations of seed rate and nitrogen rates that are replicated throughout the field. So when we look at soil variability, or we look at other variability, whether it be landscape features, elevation, slope, aspect, all those things, we can then do the analysis to determine what were the effects of those on the relationship of the different treatments that we have in the experiment. So I show this to farmers. They kind of understand what's going on a little bit. They say, wow, that's pretty complicated. We try to relay to them that we're not really asking them to do much different than what they normally do, other than to execute the prescription. They're going to drive the same way they plant, and the controller is going to do all the work. And so that kind of gives them a little bit more comfort level that as long as the technology is working, they're putting in a good experiment for analysis. Technology of equipment is important. GPS precision. We've come a long way from the early days of WASP system or GPS system, where you get some yield data and you may show that you harvested some corn in another county. Some of that data coming in. That's kind of old school kind of thing. With the new technology and all the differential corrections and the RTK system, we can do precision agriculture and be within a tolerance that we can use to do analysis. The main thing about it is the driver, of course, has to drive in the right place. Monitors and format, I won't go into that right now. I forgot my USB, but I did have one file that I wanted to bring up on that if I could. Just a second. Thank you. Could you help me? So what this is, this document, I'll be glad to share this with anybody. It's just a general document, but it lists most of the monitors or displays that are used, at least in Midwestern agriculture. I know maybe you have something different, but it allows a farmer to go, say, for instance, he's using a John Deere Gen 4 display, and it will give him all the steps that it takes to actually load the file into the monitor, and then most importantly, to execute it. Because we've had situations where the last step didn't get done. And so he ends up planting the field, and the data is all the default rate, all the same uniform rate. So the treatments didn't get to apply. So something like this document is a help aid that we've developed for them, and they can just go step by step down through that until they get to the point where they have it done. Of course, all controllers are not the same. If you're applying anhydrous ammonia as a nitrogen source in the fall, the lag time between a low rate and a high rate is going to be large because that controller is not that exact as compared to putting on UAN through a sprayer. That's pretty quick. When you're changing populations with a modern planter, that's pretty quick. So when Brittany and David talk about data analysis, they're going to talk about how they account for that lag period in the data, that they're able to sort out kind of the sweet spot, I guess you might say, in the plot, or at least part of the plot that's not going through that large adjustment phase, so that we get accurate response data from that. Calibration of harvesters. Remind your farmers, do a calibration on your combine before you do the harvest. It's not that hard. They know how to do it. Again, the problem is you're working with them at the most stressful time of the year. Have them do that. Find time to do that ahead of time and ask them persuasively, I guess, that this is important in order to have precise software. And then, of course, ag software, there's many different third-party softwares as well as the company softwares to handle equipment. Talk to your farmer about checking these shape files out, prescription files, before they go to the field. I get calls all the time. Well, I got to the field and I can't get it to work. It won't read it, whatever. Have them put it into the system, have them load it, make sure that the field prescription shows up on the monitor before they go to the field. That way they don't have to worry about that stress part of it. They'll have that done because you can preload that into your monitors and then just execute it when you get to the field. You need to confirm seed and nitrogen rates when they take a look at the experiment we give them. Confirm there's a drive line and AB line for them to start. Make it important, make sure they start at that AB line because data can get really messed up if they don't. Expertise of the operator. This is always an unknown because I work with a lot of large farmers. They have a lot of employees. Of course, some employees are tech savvy, others are not. So again, emphasize with your farmer that we need someone who is comfortable in doing technology in order to get it done right. You can design the best experiment in the world, but if they don't know how to load it or execute it, it's no good. So have them do that and make sure they have that. I will go and train anybody. If they don't feel comfortable to have someone to do that, we'll go to them and give them a training session on how to do that. Because we've had a lot of cases in the past, 6 years now, we've done that. We've got some bad results simply because simple things were not done. That includes misalignment to the design. I'm going to let David talk a minute about that on a couple of slides he had. And then, of course, data export from the monitor. Make sure they get it exported after they get done in a timely fashion. Again, on some of the older systems that had CF cards or something, that data can disappear. They think, oh, I got my data off of that. And so also had that happen where a complete set of yield data was missing because he reformatted the card. Now with the USB and all the electronic and the different software that store the material, it's less often, but make sure they get it exported and you get a chance to take a look at it before something else happens to it. David, you want to talk a little bit about this? These are kind of your drawings on misalignment.
Talk more about it. I just introduced it. I'll talk more about it in another presentation.
Okay.
So what I said was that I'll talk more about this in a later presentation. The thing is, if you're lucky enough to have a nice field where you can just drive up and down in the same direction, if the farmer doesn't start in the right place, it can really mess everything up. And so what we need to do in our software that we haven't done yet is have something that flashes and says to the farmer, start here, so that if they don't these are all software things we have to do. We have to have something when he looks at the monitor, it says, no, you're 15 feet too far west, back up and start again. We don't have that yet. And we've learned the hard way how important that is, because if I'm not going to go over that too much right now, because this is a complicated figure and I made some others. Yes.
I had the same issue with the test that I was running on the plot.
Yeah.
And what I had the producer do is at the end of the day, he has to turn and lock on the AV line
Yeah.
and shut the tractor off.
Okay.
The next morning, when he comes back after servicing and fires up, you can see that he's off. And you can center back onto the line.
Okay. Okay.
Back onto the same GSI reference.
Well, you and Bob should have a whole conversation about that. But yeah, let's continue. Yeah, sure. So Bob, I don't think I'm going to talk a whole lot because I did this in another thing. Okay, sure. This, for the most part, is pretty easy for farmers to do. But things screw up for simple reasons. And we are trying to create a more foolproof system, which is part of what the system and the cyber infrastructure I'm going to talk about later is about. We're trying to make this easier and more uniform, so all farmers go through pretty much the same experiment and make it more foolproof, really, is what we're trying to do. But all kinds of things happen. It's research, right? And it's on-farm research. It's not a finished product. So we've seen a lot of things go wrong. We're better and better. We're making fewer mistakes. So, okay. Sure. Here we go. And I've got more slides.
This is another common problem that we may have. I shouldn't say real common, but when we ask for the information from the grower early in the season, and he says, yeah, I've got a 40-foot planter and I've got a 40-foot harvester corn head that will match up correctly. And so everything will be fine. But what happens was he gets busy. He's got more than one combine. The other combine has a 30-foot head rather than a 40-foot head. And he does the yield map. And then you got things all messed up because you've got mixtures of different treatments, and only by chance every so often you get a good pass, where all the data is within that 30-foot head. So this is another emphasis that you got to remind that, we need to make sure that what equipment that we're using matches up with the size of the plot that we actually designed for the experiment. Lastly, David's already mentioned this a little bit, but I've gotten involved in this quite a bit, is our community college program. We have been going through some of the community colleges throughout the country that are interested. This year in Champaign, we have Parkland College, which has a precision agriculture program. I actually had 2 students that I worked with that actually went to the trial design software. They designed their own experiment, loaded it. They've gone through the whole process of getting it planted. If they had nitrogen treatments, getting all the applications made. And so I have just received the yield data from some of those. So we're trying to train future consultants, people to get comfortable doing this kind of thing. We're trying to reach out more to consultant types that we can work with, that we will pay to be involved, an incentive, so we can kind of expand our network and actually get to the point where consultants are actually using our software and our applications to do on-farm experimentation. So we try to get out and talk at a lot of meetings in the state, contact Farm Bureau. Also, extension events is a good place to get exposure for what you're doing. So we're hoping to increase our involvement in the next couple of years, and we hope to get consultants involved. And so once we do that, I think we can kind of get this thing to the numbers that we'd like to see for data collection. So that's all I have. So if you have any questions, or David, you got any more comments?
We're putting much more of an effort. It hasn't been important right now so much for us to try to get a hold of farm managers and crop consultants, et cetera, because we've just been working on the farmer part of this. But now that we're working more on the cyber infrastructure, where we want crop consultants to work with us, we're making much more of an effort to talk with consultants. And I've had a lot of luck. And so we're going to have a presence at booths at various state crop consulting meetings this winter and at several co-ops, et cetera, et cetera. So we're making a lot of progress on that. So it's an exciting time for us. Obviously in the center, every plot is really not very long, but on the edge, how much room, on the perimeter, how wide is every plot?
Okay. When we do the experiment, when we collect data, everything is on the outside. It's really representing the real situation. Okay. When they do this, the experiment design in there, the inside, you see that the variability of the field, the soil variability or the crop variability, it does not really align with your slices as like from the center going out. So it's like whatever the pattern is. When you do the experiment, so you have to look at, okay, the inside versus the outside, which will take more like a role in terms of like how much water you need to apply for that slice. It does not differentiate between the inside and also the outside.
Right.
So we
right.
focus mostly on the outside because that's where the majority of the area for that slice is at.
But how much of the outside? How long, say, how much of a,
For
how,
that,
how wide is that strip around the parameter of the thing that you actually gather data from?
Okay, so that also depends on the variable rate irrigation system. When they
Right.
apply, they want to do like a 1 degree, or they can actually do a 6 degree.
Okay.
So they
Okay.
really they have the gravity.
So you
really,
could have 360 different strips
yes,
if you wanted to.
that's
on
the
there.
maximum for that
And it's
implement.
It's on the 640 acre, it's on 160 acres, right?
It could be 120 acres or it could be 480 acres. It depends on the field size too.
On the field size.
Yes.
Okay. I mean, the 120 is a 120 acre circle in a,
Yeah,
60
that's a
acre square.
typical size
Yeah.
for a lot of farms in that region.
right.
120 acres or so.
And when they harvest, are you saying they go around in a circle?
Oh, yeah, of course.
I didn't
They
realize
have to
that.
do it because the crop is planted in a circular pattern.
Okay. Okay.
Yeah, the irrigation also is doing like a circular pattern. Basically, everything is based on the circular pattern is except for the irrigation pattern. The irrigation, well, the variable rate irrigation pattern is going the radial, that kind of pattern. I'm sorry, say that again? Mm-hmm. Yes. Yeah. Yes. Okay. Mhm. Okay, so for the outer edge, we don't do the exact outer edge in there. We go about 90 meter, well, 90 foot or so going inside. And then when we, based on that one, we have at least like a 90 or 100 meters for that slot area. No, I think it was 1 degree for the bigger one, the 6 degree for the smaller ones. Yes. So we usually, we will look at the design. We make sure we have enough like a length so that we can actually have the data. We also try to avoid like a between different like a experimental units in there because the water flows. You just cannot rely on that particular area. That's the exact amount of water you applied in there. Yes.
Well, no, I have a follow-up question, very similar.
Yes.
And that is actually though, when you get the data,
Mhm.
when you're analyzing it, and I think I've asked Jasmine about this, but I can't remember her answer. But there's some complications there.
Oh,
When you
yes.
use that outer circle thing. I mean, and it seems like you have to do some weighting as to what arc you're on in terms of the importance of that data. In other
Oh.
words, because you got an unequal sample, basically.
Well, when we do the sampling itself, we make sure that that length is wide enough. We actually represent, let's say that's 60 meters or 70 meters. We don't differentiate, okay, this small, that one's bigger. So it's like we sample the representative area within that particular small area. So in other words, it's like a small plot study versus like a long strip. It's like that the complication in there. We don't deal with that too much. So we at least at that particular area, we know exactly where it is. We don't worry about, okay, where
that plot is at because everything is geo-referenced.
Right,
Right.
right. No, and that's all fine. What
Right.
I'm saying is basically the inequality in the amount of data that you get at the outside of the circle versus as you move in. And that starts to change. I'm assuming, unless the cotton picker is moving so slowly. Does it move really slow?
Yeah, well, it's 2 miles per hour or 3 miles per hour
Okay,
when you
so
do the
he's
harvesting.
getting- In 100 meters, you're getting lots of data.
Yeah, we have a lot of data. We don't need to worry about, okay, I have only 1 point or 2 points. We have like at least 20 or 30 points in that representative area.
Okay, but as you move in, you start to get less and less points. Is
It's about the same thing. For harvesting, the yield monitor data, the logging is like 1 or 2 seconds. That for the data intensity is about the same. But for the outer side or the inside of the circle, we don't do actually too much inside the circle. It's like close to like a 20, 30 meters from the center. We don't need to collect any data in there because the variable rate system for that particular type of like implementation, the inside doesn't matter too much because the decision is based on the outer edge of the field. Because that area, it takes like 80% of your slices in there.
But your sampling of the entire cropped area is constrained a lot. This is actually similar to a question that we get from our farmers who want to reduce the plot size every year. In other words, they want to use what we're finding is our optimum rates of nitrogen and seeding rates.
Yep.
They want to use as a background, and then they just want small areas to be in these plots in the future. Because, and mostly they don't want any control, they don't want any zero rates, but as you can imagine, but in fact, those are critical and we're not sampling the same amount of space. So we downweight actually that information relative to information that comes from the entire field. And what we find, because we'll underestimate the variance in the spatial variance in the system.
Yep.
And that's fairly critical when your outcomes, your recommendations come as the chance of getting a particular outcome. We want to make sure we include all of that variance.
Yep.
And that actually gets back to the point of if you're making mistakes or you're not including, or you have to throw out data, the question always is, well, how much of that data was actually good enough? In some ways, I think keep it in, even though it's an overestimation of the variation. At least when we do our final outcomes in terms of the chance that you'll get an outcome, a particular outcome, that you're erring on the side of less certainty. And that's really what we ought to be reporting on.
Yeah. So I like that comment. That's one of the compromises we have to address. When we do this on-farm experimentation, the compromise would be we can collect some data, but we cannot collect too much. And one example is like, okay, for that 2017 data we collected in there, we have the 0 irrigation rate. And unfortunately, in that year, it did not bother the farmer because that's a favorable year. If we have enough rainfall so that we don't have like a significant difference between the treatments on the yield. And then later, when we try to implement the same experiment in the next year, and it's one of my friends, he told me, Winshuan, you cannot do that anymore. I said, why? The irrigation is too low. So we have to do something like in the representative area, we implement that. We collected limited data in the representative area. So we provide enough data, for example, in the representative area instead of like everywhere. So that's really, we want more data, of course. And the farmer doesn't want too much. The one I showed a moment ago, like the different slices, we didn't collect data from every single slice in there. We actually do the like 6 replications. Now each replication is 3 different zones. It's a high, medium, low. We didn't go 0 on that one. It's 0.5, 0.75, and 1 inch per week or so. So you cannot do too much.
So the entire length of the irrigation arm, I don't know what you call one of those irrigation arms,
Okay.
that has to be the same rate. That cannot be divided into sections.
Right, yes. For that particular length from the center going out, that's the
That
same.
has to be the same rate.
Same rate because it's based on the speed.
Yeah.
But now remember, there are two different ones. It's a zone-based versus the speed control. That the speed control is not really ideal, but
Okay.
that's the technology we have to implement this technology,
Okay.
the variable rate.
Yes, okay. But could you change that? You could change it so that in this 100 yards, it was at one rate. In the next 100 yards, it's at another rate. And you can do that by hand, or you can do that.
No, it's,
It can't switch on and off.
it has basically a flow meter up on
Uh-huh.
top, and so it's like a pulse system.
Yeah.
And so it pressurizes the tower, and then it's GI referenced. Each one of the sprinklers are GIS referenced.
Okay.
And so they will come on and off to apply the water.
So we could make it like a dartboard.
Yes,
You could make it like a dartboard where you had different sections.
it's about $60,000 to light up a circle to do it properly.
Luckily, Brittany's family is independently wealthy. So yeah, she's gonna finance that. That's great. 60,000, that's it? That's all? Oh, hell, that's easy. Okay, yeah, okay.
Yeah, we've got like 15 more minutes before lunch.
So to continue with the discussion of the length in the circumference, the longest arc in the center pivot, what I calculated, might be wrong, but it is 41 meters if you use a 6-degree section or slices of 6 degrees on a 120 acre center pivot. So I guess it goes back to that initial discussion. If the longest arc that you have, it's only 41 meters, then it starts to look smaller and smaller and smaller as you get closer to the center. Well, and a related point, really, this is just information, but a related point is, what type of yield monitor are you guys using? And I'm going to tell you why I'm asking that question.
Okay.
I worked with a John Deere system for 2 years, and the results were just really, really bad. The microwave system, the optical system of Ag Leader and Case IH, it performs much better, but has its issues. So for an experiment that requires precision, how do you overcome those limitations?
The youth monitor we used was very, very old. It's like a 20-year-old, and that's one of the challenges too. That particular person, he has that particular technology. He does not want to update to the newer, like a youth monitor, and we have to work with that. And even that is like one youth monitor works, the other one does not work. It's like that's what you have. You just have to work with that. And later on, actually, we lost that capability, and that farmer does not want to do youth monitor anymore. He said, okay, based on a satellite image, I can see the high yielding in the low yielding area. I don't need a youth monitor anymore. But of course, I have different opinions. Like you still have to have the real yield observation to quantify yield. The satellite image cannot really represent the real yield. So that's the consistency technical problem again. And back then, it's like we still have the 1 second or 2 second youth monitor logging interval. So that didn't bother us too much either. And for the new ones, like for this one, we have the right youth monitor for example, the John Deere one, but this person does not have the variable rate irrigation technology, you see? Yeah. It's really hard to find a combination of ideal conditions.
So when they first came up with yield monitors, whatever, 25 years ago, really were making pretty pictures. That was the main thing, right? And they didn't have to be that accurate. They just had to be sort of accurate, right? But they weren't. But now I'm wondering how hard it would be to make a good yield monitor, one that was accurate for research purposes, but on a full-size field. Could that be engineered if the companies had any reason to? And I'm saying that because if the information we're generating out of these experiments is valuable, that's way different than just, okay, I got a yield monitor because I kind of want to see how much yield there is in this part of the field, right? So if there's more value to that information, that gives John Deere a reason to make a better yield monitor. And what's your feel for how possible that would be?
Okay, so fair questions. Now, let's separate things. Yield monitors for grains are
Yeah.
really good.
Okay.
We're not talking about any small grain type of yield monitor. I'm not talking about combines. I'm talking about cotton pickers.
Yeah. And that's way different.
Way different.
Okay.
There's no point in the collection of cotton that there is an accumulation of mass that we can weigh with a
Okay.
gravimetric system, as is the case of a combine.
Right.
So what's done in a cotton picker is to measure flow.
Yeah.
As the cotton is moving from the heads to
With,
the
with
to the
lasers or
basket.
something or?
No, there are two principles of operation. John Deere went with a route of what's called microwave attenuation. Okay, so it's just a system that, and typical of John Deere, they don't tell you how things are done.
Right.
Okay? And I have plenty of experience with John Deere, so I know what I'm talking about here. But the point is, what's at your disposal as a user is calibration.
Mhm.
That's the only thing that you can do. So you go take some yield, some cotton, and then you dump that into a ball buggy with load cells, and then you input that number. I tried that for months with John Deere people. That was
Yeah.
a collaboration that I had with them. And in the end, what we said is this is a very lousy principle of operation because it simply doesn't work.
Yeah.
And they tried all kinds of different algorithms to improve it. So if things start with, I'm kind of deviating from your question, but
No, that's okay.
I just need to say this. If the principle of operation is not good enough, no matter what you do with those data,
Yeah.
it's unstable. The other option is optical sensing, and that's been much better.
Okay.
And that's what Case IH has and Ag Leader also has.
So if we want to do cotton experiments, we should get a grower with a case or
Yes.
ag leader
Uh,
technology.
If it was my decision, I'll say absolutely. Now back
Okay.
to that point. That's probably what the 20-year-old system had, because John Deere's is much newer than 20 years.
All right. All
Okay.
right.
I happen to use one that is as old as that 20-year-old from Case IH, and it works really, really well. And I treasure that yield monitor because there's only one display, the Ag Leader. There's only one Ag Leader display that can interface with that module.
Okay.
So it's a complicated situation because Ag Leader discontinued that.
Right.
So the whole thing, it kind of the background for my question is how difficult it is to do research on cotton, the level that you're trying to do. There's no commercial solution that I'll say is sufficient. It's solid, it's robust. No. My experience with the Ag Leader optical system and frequent calibration, it's been really, really good.
So say that again, but that's not commercial ag
But
leader.
it's no longer commercial at the Ag Leader side.
Okay.
It is commercial from Case IH machines.
So you're saying we could do these reasonably well, these cotton experiments with a Case IH monitor?
Yes, the answer is yes. And I will say frequent calibration. That is also back
Every
Back
day,
calibration.
every few
every day,
hours?
at least in an experiment every day.
Okay.
Absolutely.
Okay.
And maybe twice per day.
Okay.
Hold on.
Agri-plant.
It's a very small company, a one-person company who actually use this optical sensor. It's not really the mass-based sensor.
I know AgriPlan, and it's simply not supported anymore. AgriPlan.
If you, how much, I mean, are there custom, can you get custom harvest? Is there, can you get it custom harvested and maybe somebody have one of these companies has a Case IH? In other words, could you rent this? Basically,
Yeah,
but you got to have a sensor.
You gotta have a sensor to really measure on
Okay.
on the go, on the flow. It's not really about, customize your whole system to do the measure.
I have to quit because my food just got here.
but let me just say as a very last comment to that, I think that it's critical to understand too that the custom harvesters, they make money with acres. So it is, they slow down when you are bugging them with turn on your system or stop for a calibration. they will not do it. So I'll say as a challenge, it's really hard to work with cotton. And I'll stop to